All right. Thank you very much for letting me speak from a distance, and I'm really excited about the mission. You can see my screen, right?
Yes.
Right. So I would like to just throw some ideas about what I think ultrasat can do with stellar astronomy, UV stellar astronomy, and I think it is going to make a big revolution in what we understand about stars, and especially M stars. And at the end, I will talk about planet-star interaction, which is also, I think, can really make a revolution. All right. So as you all know, UV brightness of M star is varying. This is a plot from Miles and Shkolnik that based on Galax, and Galax has some like 10 or 20 measurement per a few stars, not too many. So if you compare this to what we will have with ultrasat, that we will have thousands and thousands and thousands of measurements. So the variability, the option to learn about the variability of stars in the UV is really mind-boggling. And I picked up a few topics that I think can be done with the data, but this is just a sample of ideas. All right. Yes.
Average number of exposures per star in azimuth is 2. It's not 20. The average number, so the variability is a variability based on 2 points. So it's a little bit confusing when you read a paper, but you actually get into it and examine the...
I think most of them have 10 or 20, but it doesn't matter. I just show this just to convince any reader or person that watches us that we know that all stars or most stars or a substantial part of the stars do vary on a large scale, like 50%, 90%. That's all. So one idea that is very close to my mind is detect the rotational periods of stars. And this is sometimes tricky, and I think in the UV and in the M stars, it would be even more tricky. And I did a lot of work with the Kepler data, analyzed the data, and finding the rotational period of stars. It was a revolutionary at the time because we multiplied the number of known rotations by a factor of 100 or more, and many features were discovered. So I just want to emphasize that you need, I think, special tools, mathematical tools, in fact, very simple, of autocorrelation, and which is sometimes works better than power spectrum. So here is an example of a Kepler light curve, which is spanned, as you can see, over I don't know, 250 days. And it's very, very noisy. And if you do a power spectrum, you don't find the really period. And the right thing, I think, or the better approach is to use autocorrelation function. And you can see here in the autocorrelation function, you can see that peak is corresponding to the rotational period of the star. And you can also see this decay, which is the time scale of evolution of spots, if you believe that this is coming from spots. Anyway, so we will have now, and I strongly recommend that the ultrasat will change fields, because then it will enlarge the sample completely, substantially. We will have many thousands of light curves of stars of UV, and that will be a new field to find the rotation in the UV, because in the UV probably the modulation will be stronger, and it will be masked by flares. So you need to do something to accumulate the signal of the periodic modulation. It will not be easy, it will not be trivial, but I think there is a lot of potential there. And sometimes you cannot see anything, like here. The autocorrelation doesn't show you anything. Sorry, right. So, and the modulation for Kepler in the optical band, and it will be very different in the UV, but it would be very interesting to compare that. Is here you see the period that we found, and for M stars, only for M stars, that we found 1500 rotational period, and this is the amplitude, and this is log. So this in percentage. So this means this is 1%, and this is 10%. So some of the modulation is quite large. And for example, here is one of the astrophysics that we draw from that. This is the period as a function of mass, and I guess that ultrasat will concentrate here, and we can contribute a lot to this. Here, this was the known periods before we analyzed the Kepler data. So I expect such a revolution, or even more deep revolution, with ultrasat. Now, that's came up in the discussion before. We can prepare a very good catalog of stars with deriving the temperature, radius, and mass of those stars based on the available information already known. The TIC done that without the mass, I think, but we can do it in a better way. And if we combine this with the finding of the periods and modulation in the UV, that will be, I think, a really step forward in understanding the chromospheric activity, or above the photospheric activity, the activity above the photosphere of stars. Another thing that I'm thinking of is if we find a variability, and if we find a period or another type of variability, we would be able to compare it with TESS. Gaia will have light curves, and of course with LSST and PTF and ZTF. So there is a huge space here to work on the things. Another thing is that this is done with Danny, that we compare the Gaia magnitude, which is the x-axis, and the X-ray luminosity of stars. And if you combine these things together, suddenly you discover new things. So I'm suggesting that for the stars, not only M stars, but all stars, that we will find the average UV luminosity and plot that as a function of, let's say, the spectral type or the magnitude in other optical bands. We will discover many features that nobody knew about before. And yeah, if I want to come here on this figure that we published quite 7 years ago, I think. All these red points here are stars with known planets. So it has, I mean, the rotational period that we found for the stars has nothing to do with the orbital period of of the planet. I'm not claiming that, but some of them will have planets. So that leads me to this idea of star-planet interaction. And star-planet interaction, Ultrasat has a huge potential to explain that in a minute.
Zvi, we are losing you. Can you repeat the last few sentences?
צבי? It seems that you... צבי, אתה שומע אותנו?
אני שומע אתכם, כן.
עכשיו חזרת.
כן.
תתחיל שוב את השקף הזה של ה...
את השקף הזה, בסדר, אוקיי? סליחה, אני מצטער. אוקיי, אז many people are talking about the interaction between the magnetic field of the star and the magnetic field of a planet nearby. If the planet is close enough, and if the planet has a magnetic field, there must be some interaction between the two, and we get some
Oops. Good. We are not seeing your screen now.
Okay, I'll try again.
There's a problem with the star-planet connection there.
Yeah, right. Okay. Do you see me?
Yes. Yes.
It was a disconnection.
Right, yeah, it's the connection, I'm sorry. So I'm saying that the planet-star interactions through the magnetic fields of the two is something that must occur. And if the planet is rotating around the star relative to our line of sight, it doesn't need to transit the star, even if there is some relative inclination, but the whole magnetic field, the shape of the magnetic field, the distorted magnetic field has asymmetry. And if it rotates with the planet, then we will get induced activity caused by the magnetic field with the rotation, with the orbital period of the planet. And that, I am dreaming of this for 30 years or so, to detect the activity above the star due to the magnetic interaction with the planet, with the periodic modulation of the planet. So, for example, here is a paper that I participated in writing and showing what, this is in radio, but in the UV, of course, the amplitude should be different and the shape should be different, but it's a similar idea that we try to estimate what would be the modulation here in the radio, but it's a similar approach. The modulation of the UV caused by the orbital motion of the planet around the star. And many people are looking for that in the radio. They are not looking at the right place. They are looking under the torch and under the light lamp. And I think we have a potential to do that. And I repeat again, it doesn't need to be transiting planets. Maybe we find a periodic modulation that is coincidence or it's similar or equal to the rotation, orbital period of the planet, the known. It can be from radial velocity, it doesn't need to be from transiting. Or even we can find rotation, modulation, periodic modulation, and go and look for major radial velocities and find that this is a planet. So this is really exciting. Right, and of course, in transiting planets, this I cannot put new information here, but I would say that two algorithms that we invented with Shai Zucker and are quite being used quite frequently. So maybe we can help with this as well. Thank you.
Thanks, Tzvi.
Can I ask a question?
Sure.
Tzvi, this is Oded. How deep in the stellar potential, how close to the star does the planet have to be to have a detectable variation in the UV through the magnetic interaction?
I don't know. It depends on the relative strength of the magnetic fields of the star and the planet. And you know about this much more than I do. I suspect it has to be quite near. I would say a few stellar radii.
We should probably mention the galaxy search that they try to find such interaction indications or correlation between activity.
They didn't find any.
They didn't find it, but we also should emphasize now our advantage is, again, our sample is going to be so much higher that in general, in their search to begin with, they had very, very little chance to find anything, given the fact that, again, the average samples per candidate was few at best. It's
exactly. They had, at most, they had a few tens of measurements. Compared to ultrasat, it will have, thousands and thousands of measurements. And the key issue in my mind in doing this is enlarging the sample. I remember I went with Michel Mayor when he started the search for planets, and I told him, enlarge the sample, enlarge the sample, enlarge the sample. So from my point of view, it is essential that we will enlarge the sample by looking at least a few regions in the sky. So from my point of view, all the modulation that I'm talking about, or the variations that I'm talking about, doesn't have a time scale of a few minutes or even hours. So from my point of view, I think I don't need a consecutive measurements through the hour. It doesn't matter if I will have one measurement, let's say of 3 exposures of 5 minutes, and then no information till the next hour, let's say. So then during this another 45 minutes, the satellite can point to another 3 regions. So that is enlarging the sample by a factor of 4. This is huge in terms of success.
It can also be done.
Hi, Tzvi, it's Danny. How will you tell apart these interactions with the planet as opposed to just surface features on the star, spots, whatever?
That's a very good question. I think that the planet-induced modulation will be more regular. So I expect it to keep the phase and maybe the amplitude. And this is exactly what is missing in the modulation due to spots, because spots come and go, as you know, and they change position on the star. So it's a different game completely.
Any additional questions? Okay, thanks, Tzvi.
Okay, I have to apologize. I must leave. It's a fantastic meeting, and thank you very, very much for letting me talk.
Great, thanks.
Thanks for participating, Tzvi.
Thanks.